All right, guys, so today we're going to talk about effects of changing dimension on volume. And if you remember, we did a section that was effects of changing dimension in area, and this is very, very similar. So what we're going to do to start off is find the volume of this cube, and I'm going to do it in two ways. There's the old way and the way we just learned. I'm going to start off with volume equals area of the base times height, just because that's what we've been using. Now, if I find big B, that's the area of the base. It looks like the base has a length of 2, a width of 5, so big B would be 10. Then I want to find the height of the prism, which looks like it's 4. So volume is 10 times 4, which is 40. So I'm going to go ahead and come down here and write 40 feet squared, or cubed, I'm sorry. Now, we can find volume the old way as well. I'm going to change to blue. If you remember, it was length times width times height. Now, in our case, that's 5 times 2 times 4, which is also 40. Now, we're going to use this way for today just because it makes things move a little quicker, and then you can kind of see what the dimension changes are. So remember when we did this before, this table looks very similar as well. It may not make perfect sense. It probably makes better sense than that other one did at first, but go follow through, and I promise you by the end, you'll see how easy it is. So we're going to start over here with our original volume, which was 40 feet cubed. Then we're going to change the length, width, and the height. Now I'm going to go in there as if 5 is the length, 2 is the width, and 4 is the height, just like I did up here. So I'm going to double my length. So 2 times 5 gives me a new length of 10. I'm going to make it twice as long, so that'd be 2 times the 2. So now it's 4. And then the change in height is 3 times as long, so 3 times the height, 4. Now gives me 12. Now these are my new length, width, and height, so I'm going to use those to find my new volume. So volume equals, we have 10 times 4 times 12. If you multiply that out, you get 480. Now I want to take that new volume, 480, and I'm going to divide it by my original volume, which is 40. Now you can put this in your calculator. If you do, you end up getting 12 for your answer. But just in case you were wondering, 2 times 2 times 3 is also 12. So you might be seeing how this works already. Let's go to the next one. We still started with 40 feet cubed, but this time we're going to change the length to be 3 times as long. So I'm going to have 3 times 5. So my new length is 15. On my width, there's no change. Well, no change would be the same as like multiplying by 1. So I still have 2 for my width. And then twice as long on the height, so that'll be 2 times 4 this time, which is 8. So I have my new length, width, and height. I'm going to find my new volume with them. So volume equals 15 times 2 times 8, which I got to equal 240. Same thing as last time. We're going to take that new volume. We're going to divide it by our original. If you divide this one, you end up with 6. 6 is actually 3 times 1 times 2. Okay? The last one. We're still starting off with 40 feet cubed. We're going to make the length 4 times as long. So 4 times 5 makes our new length 20. Half as long would be 1/2 of 2, which gives me 1. So there's my new width. And then it's going to be 3 times long here, so 3 times 4, which is 12. So I'm going to multiply those numbers together. My volume is 20 times 1 times 12, which also gives me 240. So that's the same as the last one. So 240 divided by 40, we already know is 6. But I got it in a different way. This time I got it from 4 times 1/2 times 3. So if you notice these numbers I've been writing at the bottom, these right here, we end up getting the same numbers that we used to scale it over here. So if you remember that from the last one, this will make it really easy. Go down back to the back, and if you would do this for me, let's put a square with a triangle inside of it. That might make it a little easier for me to see. So get these done, guys. If you have any questions, let me know, and good luck. Flip to the next page and write our conjecture. It says, write a conjecture you can make regarding the effect of changing dimensions on volume. Well, I got that the new volume is equal to the original volume but we have to multiply it by all the changes. Instead of area having 2 this time, we have change 1, we have change 2, and then of course we have change 3 this time. That's really the only difference. So now I can use that to answer the next 2 questions. Those are pretty quick and easy. It says, suppose the volume of a right triangular prism is 360 cubic units. So that's our original volume. What would its new volume be if one of its dimensions was twice as long, a second dimension was 3 times as long, and the third dimension is half as long? So we can figure this out pretty quick. I know that my new volume, and I'm basically going on what I had right up here, is equal to the original volume, 360, times my changes. Twice would be times 2, 3 times would be times 3, and half would be half. Now I can throw this in my calculator. I basically know, though, that these cancel out. If you do 360 times 3, you get the new area, which is 1,080 units cubed. So pretty straightforward, guys. Let's look at the next one. Suppose the volume of a cube is 54 square roots of 3 cubic centimeters. What would be its new volume if one of the dimensions is halved, a second is doubled, and a third did not change? So I'm going to take my new volume, or get my new volume, by using my original 54 square roots of 3 times, let's see, halved would be 1/2, doubled would be times 2, and did not change would be like times 1. So you could kind of cancel it out. But look here, guys, a half times 2 times 1 is just 1. So our new volume is 54 square roots of 3 centimeters cubed. So guys, if you have any questions, you can let me know in class tomorrow. Make sure you have all this down. And